All right, so some of you asked about your programming test 0 from last week. We already started the grading process. We'll try to return back to you, I'm hoping, maybe next Monday. Okay, I'll try. If no, you still got to take programming test 1, maybe based on the practice test. Okay, so I'll try my best, and also the TAs. And your priority should be make sure you submit lab 1 in time. I believe it's today, right? Midnight, make sure you submit in time to claim your credits. And we don't really release the lab marks. So just in case, as long as you submit before the deadline, you can be rest assured you actually got the full marks. That's just the policy. And lab number 2, I'm going to release it pretty soon. Question?
Sometimes when I check the web submit, it says I have no files submitted. But then when I log in on like another device, it says I submitted a file.
You mean for the labs or for the test? For labs. You can feel free to drop by office hour. I can double check for you. But it should be there once you have submitted. The file should be there. Maybe just make sure you log in with the right account.
Like, are there 2 different accounts?
There should be just your PPY or EECS login account. They should be the same.
It's just that sometimes it says that the file isn't submitted.
This is some possible, but you can maybe drop by. Maybe we can take a look together at some point. Yeah, good. All right, so about your programming test 1, which will be next Wednesday, right? So your programming test 1, the guide has been released, and also do try the practice test 1. I'm pretty sure that will help. And this Friday, October 3rd, we will have some in-person review session, 2 p.m., and then Curtis Lecture Hall C. I will be there, and there will be a TA also running the session together. So it's going to be good. So just come and then ask your questions.
Will the in-person review session be posted online?
So because it's mainly going to be run by a TA, so I'm not too sure if that'll be a good idea to really post their recording. In fact, I recorded that, I would feel comfortable to repost that. I cannot guarantee, but I would say if you can come in person, that'll be the best. Yeah.
Because I have work that day.
Yeah, understandable, but we'll see what I can do, but I cannot guarantee. Okay, good. I appreciate that. Okay, thank you. But guys, it's going to be a good session, so I'll make sure it's worth your time. Just come, okay, if you can make it. Okay. So that'll be about it. I think before the reading week, that's basically the last test, right? Programming test 1. And then I'll reach out to you also about your written test 1, which will come, I believe, after the reading week. Okay, I'll also give you some example questions as well. All right, let's do some recap from last time, and then we'll continue with exceptions. Today we'll do more hands-on about Eclipse and tracing. So last time we actually talked about caller versus callee. Just remember every line of method call is going to identify some caller and callee, right? From different lines of method call, you may have the same method being a caller in one, but being a callee in another. So it's definitely possible. Okay, we'll see more example today. Okay. And we talk about call chain right here, right? We're going to see that again today. It's a very common thing. You have to make sure you know how to trace. And the way to do it is by using a last in, first out stack. So the bottom method here would be the entry point of execution. You keep stacking up. And in our case, as soon as you run into a method that kind of throws an exception, the stack will stop growing, in which case you have to be subject to the catch or specify requirements. That's something we briefly talked about. We didn't say briefly, but we kind of informally talked about last time. So today we'll try to reinforce the idea using some code example in Eclipse, and also I'll generalize it as well, just to make sure it's as clear as possible. Okay, we should expect another 2 lectures for exception today, and also a little bit on today, Tuesday, right? Thursday. Okay, a little bit on Thursday as well. Okay, not Thursday. Sorry, but you know what I mean, the next class. So I just got confused with all my classes. Anyway, using a stack, we'll see more. All right, so that's the requirements for catch or specify. We'll definitely review them, every one of them. Okay, just very quickly. Rule number 1, the method that throws the exception, that's the origin of the exception, you always try to specify. You don't really try to catch it right away. You want to somehow throw that exception to the subsequent caller and see how they will deal with it. Okay, so that'll be rule number 1. And then rule number 2A, you want to make sure every caller here, they got 2 choices. Either they can simply say, I don't want to catch the exception, I just want to throw it away. I want to propagate it further to my caller. So that'll be one way to go. Or it could be that the method simply says, I want to catch it. Okay, for example, I might want to catch the exception right here, and there's an important thing which I'll illustrate to you as well in Eclipse. As soon as the very first method in the call chain catches the exception, That means any subsequent caller will not be subject to the catch with specified requirements anymore. Okay, that's something I'll show to you, don't worry. Okay. Also, one thing you gotta also remember, the way Java or Eclipse enforces the catch with specified requirements is by giving you some compilation error. They're gonna show to you maybe certain method call may trigger some exception that you have not really handled. That's something you will see. Okay, I'll illustrate that to you again. We have different versions of the code to show to you. All right, so, and this is the example we kind of started with. Okay, so let me just recap very quickly. So we basically got three classes. We got tester.main, that'll be the entry point of execution, which calls b.mb, and b.mb calls a.ma, right? So that's going to call chain. Only three methods, pretty simple to deal with. And then we say that the origin of some error would be right here in A, where the input parameter is negative. Right? So this is where error might occur. So this is telling you exception may not occur all the time, only if the I is negative. When I is not negative, exception will not occur. So what does that mean? That means at the runtime, you got to watch out for the execution flow. About the method, we said that the MA may be executed normally if the exception did not occur. Well, it might be executed abnormally, not normally, in which case the exception occurs. So we're going to see both possibilities also today in the Eclipse. So in version number 1, I'll show you just briefly about how you can use the breakpoint and debugger to really trace the error, trace the exception. But we're also going to do things on the paper as well. All right, let's now talk about version 1. Okay, and we'll do version by version. We got 3 versions in total. Let's just see very briefly about what version 1 will do. Okay. So for version 1, we kind of developed the very first 2 classes last time. So we got class A, we got class B, right? So for class A, we got method MA, which has an input parameter I. If I is negative, right here, let's say we're going to print out some line. Okay, we say I less than 0, that means it's abnormal. The input is kind of invalid. So you say abnormal execution of A.ma, which is this method here, A.ma. And then we're going to throw new exception, right? We also showed to you last time about how you can create a new exception class. And also you're going to practice that in lab number 2, all right? If I is not less than 0, then we simply print out normal execution of A.ma, right? Just to show you the flow. And we also got class B here, which is the caller of A.ma. So MB over here, simply do the try and catch. If you recall from last time, before I didn't really have the try and catch block. I only had just a single method call, in which case we got to get a red underline for OA.ma because the exception is not being handled. So one way to handle the exception is by using the try and catch block, right? So we just chose one, all right? But another possibility would be maybe B.mb, try to specify it. That'll be version 2, which we're going to see in a moment, all right? So that's about the recap from basically last time, okay? So now here's one important thing to notice right away, all right? So what we have got so far, A.ma has thrown the exception to the B.mb because we say throws. That's a specify option. And then B.mb right here, if the exception is thrown, it's going to catch that, which means the exception will stay in B.mb. It's not going to be propagated any further. So that means if we now create the tester.main method right now, which I'm going to do, and we try to call b.mb, are we still subject to the catch or specify requirements? The answer should be no, all right? So that's something you want to really see, both conceptually and in reality, okay? So here you can say, since b.mb catches exception, catches the negative value exception, subsequent caller no longer subject to the catch or specify requirements. Right? It's a very important point to, first of all, understand conceptually. Right? That's also something we said in that stack page last time. Let's now verify this in Eclipse. Okay, let's see. So let's go to where we were from last time. Okay, so we are still in version 1. Okay, I'll create version 2 in just one moment. Okay, so we got version A here. And you can see that in version A, we do have that if condition, right? If I is less than 0, we're going to throw that exception. And in B.MB, we chose the catch option. So we're trying to call OA.MA, which might throw that exception, right? That's the catch option. So now at this point, the exception has been caught already. Let's now create a further caller for B.MB. Let's try that, okay? And we're going to see what happened. So what I will do is I'm going to create in version 1 a new class. Okay, right click and say new class. Let's call that tester. And then I just want to create a main method. I can click on the checkbox and Eclipse can create that main method for me. All right. So I'm going to say finish right here. All right. So we got tester here. All right. All good. And this is what I'm going to do right now. So let's say I want an integer value. So in the slide example, I also kind of showed to you how you can use a scanner to read the input from the keyboard. But now for demo in the class, I'll make it a little bit simpler, just some integer variable. And then let's say integer I will be, let's say 5, for example. So 5 is considered a valid value, right? It's not negative. But we can change it a little bit later. And then I'm going to create an instance of b. OB new b. And then I'm going to call that method there, right? So basically, I'm going to call B.MB. You hear? And remember, B.MB already catches the exception, right? So now, let's see what's going to happen. If I say OB.MB, and then I'm going to pass I. All right? So now you can see that everything compiles. Agree? Everything. Because if you just go back to the package explorer, you can see there's no red underline for the project, for example, and no red cross for any of the classes. So this actually compiles. That's simply because at this point, let me repeat again, and we're going to see in version 2 that can even contrast what's happening here. The exception was thrown from here. And then the caller here, B.MB, catches that. So that's why the further caller here is no longer subject to any catch with specified requirements, right? That's number 1. Let's now do some tracing, all right? So for the tracing, let me do on the paper first, and then we'll do that on the Eclipse as well. So this version 1 might be the only one I'm going to do a little bit more detail about tracing using breakpoint debugger, but you should really try version 2 and 3 as well later, okay? Let me just answer 2 questions very quickly. Is B.MB subject to catch with specified requirements? Indeed, it is, because its callee over here, A.MA, throws the exception. So this one here is yes, because its callee, A.MA, specify it. And what about tester domain? Is it still subject to the catch with specified requirements? In this case, no, right? Because it's callee B.MB catches that exception. All right? Let's now talk about 2 different input values, and then we're going to trace the code together. All right? So the first value I'm going to see will be, let's say, plus 5. So let's say integer I would be equal to 5. All right? And let me remind you very quickly about the call stack, right? So the entry point of execution is going to be tester.main. So tester.main, which calls B.MB, which calls A.MA. And then the A.MA may or may not throw some exception, right? May or may not. As soon as A.MA terminates either normally or abnormally, we're going to stop growing the stack. Okay, let's see the first input here. All right. So we're going to do the label, 1, 2, 3, 4, 5, etc. Okay. So I'll make it slightly bigger, slightly. Okay, so 1 should be when we assign the variable value I to be 5. Number 2 should be when we create that context object. And here we don't really have to draw the box for B. It's not really the focus point. The focus point should be to look at the stack to know where we are and also to see whether the exception has been thrown. That's all we need to know at this point for tracing. Okay? And then we're going to go for number 3, right? You can see number 3 here is a method call. That means we shouldn't really go to the next line to print out something until B.MB here it's finished. all right? So that means we should really step into MB. And the value we are looking at is 5. So we go to MB right here with the value 5, all right? So number 4 should be create that context object of type A. And then we're going to go into the try block, right? So sometimes you may just put a label here just to say in the beginning of try block, but we don't need to. We can simply say the first line of the try block. That should be enough. Okay. So number 5 should be we call this method from A.ma, with the value 5. And similarly, we don't really go to the next line until this line of method call terminates, right? So we're going to step into it again. So we step into it, go to MA right here, and with a value 5. And we're going to do number 6, which will be to check the if condition, right? So 5 less than 0, false. Agree? So that means we're going to go to the else part. If we go to the else part, we're going to print this line here, number 7. So also good? All right. What happens after 7 here? After 7 here, we basically are done with the if-else statement here. And there's no further code for the MA. So we're basically done with MA. So when we're done with it, we are simply going to remove it from the stack. You can think about the removal of A.ma in this case is because it terminates normally without any exception. So we remove it from the stack. Question for you. So now, so far we got to 7, right? Where should 8 be? 8. Which class? First of all, tell me, which class? Go ahead. B, okay, because you can see this is active right now, right? Beta MB, I suppose, and then where? Print line? This one or this one? First or second? First one, right? Because this was where we were before it was suspended, right? So now this should be where we should resume. All right, so this will be number 8. So number 8 here will be some print line, okay? And I'm going to write it down right here, okay? So that will be from B.MB calling A.ma did not cause the negative value exception, right? So that's the first line being printed, okay? I'll just highlight it, okay? Right here. All right, number 8. So after number 8, we're basically done with the try block, right? We have done with the try block without being caught to any of the catch block. That means no exception has been occurred. So the catch block will all bypassed. We don't really execute any one of them. You can see there's also no further code after the catch block. So we are done with MB. All right? So now we are done with MB, so remove it from the stack. So MB right now also terminates normally. Question?
So if try CPUs, then catch doesn't?
Thinking this way. So when we execute line by line in the try block, right? As soon as a method call in the try block throws some exception, it will be interrupted and go to the relevant catch block and go from there. But in this case, since the only method call that may throw some exception did not throw the exception. Because it's 5, exactly. So this is only for this particular input. But we're going to try another input, which is going to trigger some exception. We'll see how that goes later. Okay? Question?
The method that throws the exception be the one that handles it? For example, can A throw the exception MA and also handles it?
Yeah, exactly. So that's something we said earlier. So for A.ma, which throws the exception, you can try to catch it right away in the same spot. But that's not normally the practice. Because when you actually want to throw this error here, you want to signal to your caller that, oh, you passed something wrong to me, so you better handle that. You don't really try to handle by yourself. Not typically. Yeah. Good question, but I think just in common practice, you will try to, you don't really try to throw and catch at the same time, even though you could programmatically. But design-wise, you wouldn't do that. Okay. All right, so now we are now in number 8. So after number 8, we're done with MB. All right, so it's removed. So go back to tested domain, right? Similar concern. So now we are back to where we got suspended for tested domain. So now we're going to go for number 9, which would be to print this out right here. Okay, so for that one there, we're going to say from tester domain. tester.main, and then after calling b.mb. Right, so these are the two lines that will be printed out for input value 5. All right, you can think about that's more like a normal execution, which we did, in the method call chain example that we first did. No exception, right? But let's see, side by side. If I modify the value, let me do another execution run where I is set to be, let's say, -4, let's say. Okay, let's see what happens. And that'll make some comparison to you as well. All right, so let's now do -4. Okay, just by side. Okay, just pay attention to the red. We're going to see also exactly how the labels are going to change. There will be some parts they will share, but there will be some parts that are different, right? Let's watch out the difference. So we start with initializing the variable here. That one will be the same, so 1. And then we create the context objects, OB, and then we try to call that method MB. And this time, the value will be -4. All right? So we go to MB for the second time. And the I here will be -4. So we're going to go for number 4. Number 4 will be the same, just creating OA. Let me just write a little bit better. So number 4 is right here. Okay? And then number 5 will be to call MA with -4. All right? And then number 6 will be where you try to step into MA, but now with the value of I being -4. So now we're comparing number 6, the same if condition, so -4. So -4 less than 0 should be true. So you can see from number 1 all the way up to and including 6, same for the two cases. But here is where the difference is going to come. Because we got -4 less than 0 being true, so we're going to go for 7 right here into the if block. And that one there is going to print out this one here. All right? It's going to say abnormal execution of A.MA. Abnormal execution of A.MA. And I do apologize, I forgot that when we first went to the previous input, right, we should have printed this out. I forgot to include it, right? So that one there should be normal execution, right? Just in case you spotted that. Execution of A.MA, all right? But there should be no confusion, all right? So now after 7, we're now going to throw that exception. So this will be number 8, right? We're going to throw that exception. As soon as the exception is thrown, you can think about this method here terminates right away, but abnormally, not in the normal way. As soon as the exception is thrown, because we try to throw that exception, it's specified, right? We're going to also remove A.MA from the stack. So I want you to compare. After executing 8 here, and after executing 7, both will make MA terminates, but in a different way. After executing the 7 over here, A terminates normally without any exception. But after executing 8 right here, is going to, MA will terminate abnormally, right? Just notice the difference, all right? So number 8 here, and now where should number 9 be, right? That's a question. Since we are now going to resume back to B.MB right here, B.MB was suspended right here, right? So we should really go to the next line. Oh, sorry, not the next line. Okay, this is a critical difference, right? This method here actually threw that exception. That means when the exception is thrown, let me just draw some visual here. You can think about for this particular input, the negative value exception is thrown from this line here. As soon as it's thrown, the line is going to be interrupted. That means it's going to find out the relevant catch block and be caught right from there. So that means it's going to match this particular catch block, right? And then it's going to execute this line only. So it's going to be number 9 right here. Guys, any question about number 9 here? Okay, let me say one more time. When we actually make this method called OA.MA, because the value -4 is going to trigger that exception to be thrown. That means from this line here, when this exception is thrown, it's going to be caught by the relevant catch block. In this case, just the only catch block that would match. And then from there, we're going to print out this line. All right? So that line there is going to be calling this cause the negative value exception. So B dot MB calling A dot MA caused the negative value exception. Okay? After number 9, we're basically done with the catch block. And after catch block is done, we're done with the try and catch block. We don't really go back to the try block, right? It's already interrupted. So after 9 here, we're just going to remove beta and B as well. All right? Now, question for you. When we remove beta and B, is the negative value exception still there? No, because it's already been caught, right? It is very important to remember this, right? When you remove beta and B over here, the negative value exception is propagated. Oh, beg your pardon. It's actually for the next version. I don't want to confuse you. I'll write them properly. For this red over here, right? When you remove this, the negative value exception is caught. And also not propagated any further. Not propagated any further. Okay, that's important, right? So now where should number 10 be? So now we going back to tester domain. So this is where we got suspended right here, right? So we should still go to just number 10 right here. So we still print it out. So still print that line. So tester domain. And then after calling B.MB. All right, so that's the lines. So let me just highlight them quickly. So you can see this line here and also this line here. But for the same line, it's actually being printed for both execution flow. All right, so these are the two cases where number 5 here is going to not cause any negative value exception, but -4 is going to trigger that exception. All right? Question?
No one put exceptions from one part, for example, can you do new value exception and stackable flow, for example, from one code, so that the caller should now handle 2 exceptions at once?
No, whichever exception is thrown first, you will handle that. You don't really try to.
You cannot throw multiple at a time, right?
You cannot throw multiple at a time. So as soon as the very first exception is thrown, you got to handle that right away. Yeah. In some way, it's simpler, right, to handle at the runtime. You don't have to handle multiple exceptions at the same time. Yeah. All right, let's now try to verify this in Eclipse, right? So I'm going to just do, maybe, how about this? Let's just do -4 right here. I'll show you how you can do that on the Eclipse, right? And you can also try for 5 as well, okay? Especially, we're going to see how the exception is being thrown. So let's go to tester domain right here. And then I'm going to put a breakpoint right here in line number, how about 7, okay? Right after I is assigned. Let's say we try -4 right here, okay? -4. We know that at some point it's going to trigger the negative value exception from A.MA. That's what we know. Okay? And let's now launch the debugger. Okay? I'm going to show to you about this particular input 3 passes. We're going to see at different levels. Okay? Level number 1. Okay? Switch. Okay? Yeah, just bear with him. Okay, line number 7, right? You can move your mouse over just I right here. You're going to show the value -4. All right, and then I'm going to say step over, and I'm just about to make the method call with -4. Okay, now if I try to step over, am I going to see any exception here? That's a question. Right? So if you recall on the paper, right, we said something like that. This one here, be calling Beta.MB, even though Beta.MB itself is going to get some exception from A.MA. But that exception is caught already here. So that means the exception is never propagated to tested domain. So we wouldn't see any exception here. All right? But in later version, we'll see that. Okay? So let's go back here. If I say step over, okay, I just go all the way to line number 9 at the end. So these are the printout. Okay, that's level 1. As far as the tester domain is concerned, I don't really see any exception object here. I don't need to specify, I don't need to catch, and also even though exception may have already occurred, it's been caught already from beta and B. So I'm not, simply don't see anything here from tested domain, right? That's point number 1. Point number 2. Let's now launch the debugger for the second pass. Okay, so now we are in the same place. Sorry, let me do it again. Let me stop it. Okay, we're going to stop at line number 7 again. All right, so it's still -4. And I'm going to step over here. All right, so now rather than stepping over, I'll step into beta and B. So if I step into, I'm now in the context of class B, right? And then I'm going to call A.MA. All right, so here I value, remember, is -4. Okay, let's now try to see what we learned from the paper. I'm now in line number 9. If I actually execute this line, I know that -4 is going to trigger that negative value exception. If I say step over, where would I go? Tell me a line number. Let me repeat my question. This is important, right? Now the breakpoint stop at line number 9, right before I execute OA.MA with a -4. If I say step over, I know that somehow the negative value exception will be triggered. But now if I say step over, which line would I go in the same class? Patricia? Line 12 is somehow the catch block, right? It's a good concept, right? Good. But let's see. At least we know it shouldn't be line number 10. It shouldn't be, because it should be interrupted, right? So what we could do is we can say step over. You're basically right, but somehow the Eclipse wouldn't show you actually match the catch block. You just show directly the first line of that catch block. It's really the same thing. All right, so line number 13, all right? That means the exception occurred from line number 9. So we bypass line number 10. Okay? And then after the catch block, if I say step over again, it is simply just go to the end of this method here. Right? And now if I say step over, where would I go? Back to the entry point of execution, tested domain. Very good. Okay, I'll just do that just to show to you. Yeah, you're exactly right. So basically OB.MB, we're just done. All right, one more pass. Okay. Now we're going to see where the exception can be originated. So let's now launch the debugger one more time. And then I will say step over. All right, let's say step into. Now we are in A.MA, which we saw earlier. And then here, rather than stepping over, let's say we step into again. We're going to see exactly how this I value, remember I value is -4. All right, let's now step into it. We're now in A.MA, right? I value is -4, less than 0, true. If I say step over, right, it's going to go to the if block. And step over, so now it's right before I execute line number 9, right? Now, question for you. If I say step over, what's going to happen? Conceptually, it's like the end of the method, but remember somehow the method will be interrupted, it will terminate, right? So let's see this. I believe what Eclipse will show is this. Thinking this way. So now we are basically throwing this exception here. As soon as it's thrown, we'll simply just terminate MA abnormally. And we'll just go directly to, so this line here is going to throw that exception. So we might just go to the catch block directly. Okay, so that's something we'll see. Let's double check. If I say step over, right, we go directly to the catch block, right, because the exception is thrown. All right, there's some subtlety you want to watch out for. Right, and then we're going to match that catch block, and then we're going to print out the line, right, like what we said in the paper. And if we say step over, then we go back to the entry point of execution, right? So these are the 3 passes. I would suggest when you go home and study this lecture here, at least try to reproduce what's happening over here for each version, especially when the exception is thrown. All right? Guys, any questions? So version 1 will dive into complete details, but I'm going to show to you about version 2 and version 3. They will just create some slight variants about how you may implement things differently, but that's something we're going to see. All right? If you're okay, let's now move on to version 2. Okay? So let me first of all talk about how version 2 is going to be planned out before I start doing it on the Eclipse. So version 1 is done. So version 2. Version 2 here is interesting. You can see for A here doesn't change, right? A always is the origin for the exception. But for B here, rather than it's, remember in version 1, we do try and catch. Let's say we don't do that option. We do specify. Okay? So that means in B here, we're going to do specify option. All right? Now, there's a little question you can notice, right? Notice what I'm going to do here. Okay, let's now just go back to here. And then I'm going to just copy version 1, verbatim. Copy that. And then under the source, I'm going to say paste. I will call that version 2 right here. Okay, let me close everything about version 1 just to avoid confusion. And then I got version 2 here. A stayed the same. But for B, I'm going to change from catch option to specify option. So I'm just going to remove, first of all, the try block and catch block. And then fix the indentation right here. You can see that if I only got the method call here, I still got compilation error because I haven't done anything, right? I haven't done specify or catch. Let's now do the specify option. So here I can say throws negative value exception. All right? Question for you. You can see B here compiles, but we got trouble for test to the main. But test to the main actually got compilation error. Remember, we simply copy and paste from version 1. Version 1 for test to the main is no longer subject to the catch or specify requirements. But now, suddenly, if you move your mouse over here, it says the exception is unhandled. Why are we suddenly subject to catch or specify requirements? That's a question for you. Go ahead.
Because ob.mb throws an exception and you don't handle it inside the testing class. So it gets
exactly. All right, I think your fallacy was exactly spot on. Okay, let me just say that again. In version 2, A here throws the exception, specifies. B.mb also throws the exception. So that means this one here is still subject to the catch or specify requirements, right? So when you really want to compare version 1 and version 2, why? Changing this method here from catch to specify option is going to require different things to be done in the subsequent caller. All right, so that's the main thing you want to really make sure you are convinced. All right, so yep, that's it. So what should we do? Apparently we got options here. Let's say we catch right here. So what I can do is I can simply go back here. I can say I will try to execute this method here. And then I will catch a negative value exception. So let's say E, doesn't really matter. All right, so now everything compiled, right? I choose the catch option. You might be wondering, what if right here in the last caller, basically entry point of execution, what if I also try to specify? Version 3. Huh? Somehow you will throw the exception to the console. Okay, I will see that version 3. Okay, bear with me, but I do want to say a little bit more about version 2. Okay. All right, so let's say for version 2 quickly, right? So what you want to know is these two questions, right? B.mb, is it subject to catch or specify? Yes, for the same reason. Okay. For that one there, I can tell you, I can just copy that explanation. Oh, sorry. I just uncopied that. Okay, let me just write it. Yes, because A.MA is callee specifies it. Now, similar question here. Tested MA, is it subject to it? Yes, because B.MB specifies it. You can see the answer is different to the same question. Yes, because B.MB specifies it. So we basically got specify from the origin, specify for this caller, and also specify. Oh, did I say specify? It's actually catch. Beg your pardon. Specify is in the third version. But this one here, we say try and catch. But this one here could be specify option, but that will be version 3. All right, for version 2, I'm going to assign maybe 2 exercises for you. I will suggest you try both on the paper and the Eclipse. You may actually want to try 2 different values. Again, why don't you try 4 and also -5 to see how the execution flow is going to go. You'll be very similar to version number 1, very similar. Okay, you just got to trace it and see exactly and label the numbers. Okay, if you got trouble understanding this, reach out. We can talk. Final version, right? The final version here, we're basically going to see specify option all throughout. So we got specify here. We got specify here. We also got specify here. We got 3 specify options. Programmatically, nothing wrong, right? You can see it's going to be propagate, propagate, propagate as well. But let's see what's going to happen, right? So let's go back to Eclipse here. Let's create version 3 very quickly. So copy version 2, and then I would say it's version 3. And I'll close everything about version 2. A and B stay the same. You can see for A here, it is the specify option. And you can see for B.MB here, it's also the specify option. And also for tester.main, it is also going to be specify option. How do I create it? So let me say I remove the try and catch block. At this point, it wouldn't compile because I haven't committed to any option just yet. But let's now do the specify option, which you wouldn't see very typical for the main method. But doesn't mean we cannot do it. Throws negative value exception. All right? So this one here is actually going to also specify as well. Okay? And why don't we try the value of -4? And what's going to happen here? Right? Basically, the exception is not being caught anywhere in the caller, in the call stack. So that means as soon as the call stack becomes empty, the exception object will be thrown back to the user of the tester domain. So what we can do is we can just go back to Eclipse over here, right-click, run as Java app. What you will see is something like this. Right? You can see the negative value exception is thrown. Right? You can also try to look at it so it's more like a call stack telling you where the exception was generated and also thrown. Right? That's version 3. So this will be something you really want to avoid because when you are programming your application, you want to make sure along the call chain, at least one caller should really catch the exception. You should never be thrown directly to the console, at least one, right? It should be that. You shouldn't be that all the caller would choose to specify. That's something you should really avoid. All right, any question about version 3? All good? Okay, let's answer this question here quickly and then we'll take a short break. So this one here, it will be yes. Because A.MA specifies it, so we will be subject to it. Also, this one here will be also yes. B.MB specifies it. All right, all the 3 versions. Guys, final call. Any question about these 3 versions here? Anything that's kind of not clear? Go ahead.
Is there like a possibility to catch the exception translate?
Yeah, well, again, so class A is where the exception is originated. Programmatically, yes, you may throw the exception and catch that in the same method. It is possible, but it's not recommended. Because whenever you throw that exception in the very first place, it is to let your caller know there's something wrong. You want to let at least your caller to handle that, not yourself. Otherwise, you might just do something else rather than throwing an exception. Throwing an exception is really to signal the error to the public, not just to yourself. So you wouldn't do that as a design. Yeah. All right. All right, so why don't we take a short break? So there was a Wi-Fi issue for your Section B fellow students, so I didn't take attendance. Let's not take attendance for today. All right, so we'll just take a break. Okay. All right, so we're now done with that example version 1, 2, and 3, right? So just once more, I will highly suggest you try to really repeat the tracing exercise I did, both on the paper, on the Eclipse as well. And for version 2 and version 3, also try them out as well. There will be questions, maybe in your written test, about how things should be traced, right? So it's good for your knowledge as well about understanding exception, okay? What I want to do now is let's now try to generalize about how exception should be perceived or understood in general without being stick to a certain example, right? The best way to do it is make it a little bit more symbolic, okay? So bear with the symbols. I'll go over with you every line, okay, about this symbol here. So here, this will be the most general form of a call stat you will see. We just simply got an arbitrary number of method call. All right, so let's say we got the following, okay? Let's say this method here at the bottom here is the entry point of execution. Entry point of execution. And of course, this method here calls this method. This method here calls this method. And also, finally, this method calls this method. And let's say maybe somehow this method here is where the exception is originated, let's say. All right? So we assume that this is where the method exception is originated. So some exception is thrown. And as a good practice, we don't really try to catch it right away. The earliest point to really catch this exception should be the next caller. That's the earliest point, typically. All right? And then they will specify. Option will be chosen. All right? So we got basically the entry point and also got the last point of where the exception occur. How many method calls do we have? It's a quick check. How many? Can you see the pattern here? N, right? Okay, you can see here I got 1 all the way to N, right? And also to make it general, I just make different class. Class 1, class 2, class 3. But of course, it could be, some classes might be the same, right? Just make it as general as possible. So here we got N method call in the call chain. So we got a call chain of N methods. Okay, all good. All right. And let's now make a small assumption, okay, to really talk about everything else. Remember we said earlier, it should be a no-no situation to say every method is simply going to specify, in which case even the last method is going to specify and throw to the console. That's something we want to avoid. So at least one method somewhere in the middle should really catch the exception, right? At least one method. So let's say this is the method. That's the assumption we are making. So the assumption is ci.mi is the very first method. From the top, right? So you can think about from the top, right? So if we scan through M1, M2, M3, all the way to MI, MI is the very first one that has a try and catch block to catch the exception. That's the assumption we're making, okay? The very first one. Catching the exception. Once we identify this very first point of catching, we can talk about everything else. Right? So that's the assumption you want to make sure you kind of understand, okay, from the top, the very first one. And of course, we're talking about catching. And also is the first one. Okay. Let's answer several questions here. Okay, the first question here, origin of the exception will be C1.M1. All right. And now the second question here. We're talking about what are the methods subject to the catch or specify requirements. I'll let everybody think, okay, and then I will hear your thoughts. Okay, think about, I can tell you, once you answer this question here correctly, everything else should be simple. So the question is asking, assuming that ci.mi is the very first method from the top that will catch the exception. In that case, what are the methods that are subject to the catch or specify requirements? Remember, to be subject to catch or specify requirements, you must either catch or specify. Both should be somehow counted, right? That's my hints to you. Okay? I'll wait a little bit longer. Okay? Anyone from here would like to try? It's okay to be wrong. If no, I can ask your fellow student from the other side. It's okay. Go ahead.
All the way from
C1 and N1, the first one, right? All the way to?
CI minus 1. No, wait. CI the 10.
Okay, let me just make sure I heard you correctly. Are you suggesting from here all the way to ci.mi? All these are subject to catch or specify. Okay? Now, remember we said, I agree, that's correct. Okay? But now let's divide even further. We said that if you are subject to catch or specify, you can either catch or specify. What exactly are they in these methods?
So from
How many catch and how many specify?
1 all the way up to I minus 1 is specifying,
Uh-huh.
and CI the MI is catching.
Catch, since which we assume. Okay, very good. Okay, good. Let me now say this. Because this is the very first one we said it catches. If there was an earlier method that catches that, it doesn't make sense because that means there's no way for you to even reach this point to catch. The exception is not even propagated further, right? So let's now, that's exactly right. So let's do the annotation here. So right here. All these methods here from M1 all the way to MI. So they are subject to catch or specify. Subject to catch or specify requirements, all these. But let's subdivide them. Basically, the first I minus 1 method, okay, up to here. So this one here, I can say C1.M1 to Ci minus 1 dot N I minus 1. They specify. Oh, they specify. That's correct. And this one here catches, right? Exactly. Okay. So methods subject to catch with specify, we got I methods in total. Where we got I minus 1 methods specify. And only one method catches. Are we okay with that? Well, you got to distinguish between the two cases for when you are subject to the catch with specify. Right? And the question here should be quite easy, right? What are the methods free from the requirements? From where? It's right, all the way, right? Because a subsequent caller. That's what we said earlier, right? Very good. So you can think about from here all the way to this one here, beyond that point where we first catch. Okay, so over here, these are the ones free from catch or specify requirements. How many are there? How many? N minus I, agree? Right? Because you got N methods in total. And this part here, we got I methods. So N minus I, right? N minus I methods. All right? All good. All right. And then let's answer the next two questions quickly, right? So we just talk about two extreme cases. One extreme case would be we want to handle the exception at the earliest point, right? Again, we said that programmatically, yes, you can try to catch the exception where it's thrown programmatically, but it's not typically the case to do, right? So the earliest point will be this method here, okay? So this one will be like a C2.N2 catches it. The exception. On the other hand, the other extreme will be all the methods over here, including the entry point of execution, like a version 3 we saw earlier, all of them specify. In that way, exception, once it's thrown, it's going to thrown all the way to the console, for example. Okay? So this one here is going to be C1.N1 all the way to Cn.Nn, all specify. Okay, none of them wants to catch the exception and do something about it. All right, any question about this generalization there? Right, it's going to help, right? So later on, when we talk about like a different scenario, you just always remember how to identify that point where we catch the exception. All right. Okay, so I just want to talk about one thing. I think today we can finish earlier because somehow we are very much in sync with section B. Okay, I want to mention two examples very quickly, and then we'll do the tracing next time. Okay, so just more example about exception handling. So we have a class called circle, right? So here we got circle class. And then we have the method called setRadius. And then we say the radius r, if it is negative, it's like an error condition. Otherwise, it's not error condition. Pretty much like what we said for version 1, 2, and 3. And then we got another class over here, circle calculator 1. And then we got the main method right here, right? That one there is where we're trying to call that setRadius method over here. And we might pass different values over here. Right? So next time, I'm going to maybe just trace very quickly about if you pass 10 or minus 5. It's basically what we did for version 1, 2, and 3 about the tracing, right? But that's something you can also try. But at the call stack is going to look something like this. You got the circle calculator 1 dot main, which will call the setRadius from circle. Circle dot set radius, right? So these are the two methods in the call stack, right? So that's the enough hints for you. So I would say you can give a try on the different input value. We can try that very quickly, maybe when we resume the lecture next week, okay? So what I want to do, not next week, again, I got confused, next class, that's safer to say. And then what we want to do now is to look at this one here quickly, okay? The next version, still the circle calculator, but I extended the code a little bit right here. What we want to say is something like this. We're going to prompt the user to really enter some radius, okay? Right here, okay? So let's say the user, okay, let me use a different color here. We're going to prompt the user to enter radius. If they enter -4, the program is going to prompt them for another number. Let's say I enter -5. Also invalid, which is going to trigger some exception somewhere, by the setRadius. If I enter -2 again, it's going to keep going until the very first number that's actually correct. Let's say if I say 5 right here, and then 5 is going to be used to calculate the area of the circle and return the answer back to me. So all these will be like a single run of the program. So the way to do it is by using a while loop. And I want you to study this pattern here about using a Boolean variable to control the entrance and exit of the while loop. Okay? So the Boolean variable right here is called whether or not input radius is valid. In the beginning, we simply assume it is not valid, so it's false. Okay? And then we have a while loop here. And we say that we're going to stay in the loop as long as the input radius is not really valid. So we got a negation, right? As long as it is actually remain to be false, we're going to stay in the loop. Okay? Of course, in order to make sure we don't really have an infinite loop, we have to somehow set this Boolean variable here to be true at some point, right? You can see we only set it to be true right here. Okay, right after calling this method here without having that negative radius exception. That's number one, right? You want to take a look, and then this is where the Boolean variable is reset to true. And as soon as it is true, it's going to evaluate to not true, which will be false. We can exit from the loop. Okay, so this will be the program I'm going to maybe also trace with you also as well, just to see how it will work. So it's also an important pattern for you to see how to use a Boolean variable. All right? Any questions? Okay? If you guys are okay, we'll finish the class earlier today because that's really what I have covered from for your section B fellow student. I want to keep in sync. Do you guys have any questions for me? No? Okay, if you got a question, I'm willing to stay a little bit longer to answer questions. Otherwise, I'll see you next class.